It is a cell or a device which always converts electrical energy into chemical energy or chemical energy into electrical energy. What is electrode potential? It is a potential differences which exists between the electrode to its own ions at equilibrium. So, if the electrode which has a rich electron to supply for the other electrode, hence it is known as a negative electrode. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Electrochemistry. Under that, we have studied about the electrolytic cell and electrolysis. Is it right? So, we have understood that what is the electrolytic cell and how the electrolysis will be taking place. In addition to that, we also discussed about the quantitative aspects of electrolysis. So, under that, we have studied about the Faraday's first law of electrolysis and also we have studied about the Faraday's second law of electrolysis. Today, let us move on to the next topic of this unit, that is electrochemical cell and its type. So, today we are going to understand what is actually a electrochemical cell and how they are classified. In addition to this, we are also going to understand about the electrode potential. And also we are going to understand about the standard electrode potential and the Daniell cell and symbolic representations of the Daniell cell. Okay. First, I will directly move to the electrochemical cell. In electrochemistry, the electrochemical cell, which is referred as a device which converts electrical energy, into chemical energy. Which converts what? Electrical energy into chemical energy. Or we can say that it is a device which converts chemical energy into electrical energy. Okay. So, this is known as electrochemical cell. What is the electrochemical cell? It is a cell or a device which always converts electrical energy into chemical energy or chemical energy into electrical energy. And it has been broadly classified into two types. The first one is a galvanic cell and second one is a electrolytic cell. Already in our previous classes, we have understood about the electrolytic cell, right? So, what is the electrolytic cell? It is a cell which converts what? Electrical energy into chemical energy. Which converts electrical energy into chemical energy. Chemical energy. Okay. Today we are going to discuss more about the galvanic cell, which is also known as voltaic cell. Voltaic cell. Okay. Galvanic cell or voltaic cell. So, in the galvanic cell, it always converts a chemical energy into electrical energy. Chemical energy into electrical energy. This is known as galvanic cells or the voltaic cell. So, what is a galvanic cell? It is a cell or a device which converts chemical energy into electrical energy, whereas electrolytic cell is a device which converts electrical energy into chemical energy. And one more thing is, in case of this galvanic cells or in the voltaic cell, always the spontaneous redox reactions will be taking place. So, here always I can write here spontaneous redox reaction will be taking place. spontaneous redox reactions will be taking place only in the galvanic cell. Whereas in case of electrolytic cell, in this type of cell, always it need a extra energy to carry out the reaction. So that is why it is known as a non-spontaneous chemical or redox reaction. Non-spontaneous redox reaction. Understood? So this is the differences between the galvanic cell and the electrolytic cell. So what is the electrochemical cell? Remember, in electrochemistry, we used to say that it is an electrochemical cell. Then what is that? It is nothing but a cell or a device which converts electrical energy into chemical energy or chemical energy into electrical energy. And also we have classified these electrochemical cells into two types. The first one is a galvanic cell or voltaic cell, and second one is a electrolytic cell. And we have already understood about the electrolytic cell, right? So this is the cell which converts electrical energy into chemical energy, and this kind of cell or in this type of cell, they need extra pressure, or we can say that they need extra energy to carry out the entire reaction. Hence it is named as non-spontaneous redox reaction. Coming into the galvanic cell, here it always convert a chemical energy into electrical energy. For this kind of cell, they do not need a external energy. Hence it is known as spontaneous redox reaction. Remember, in these two kinds, the redox reaction only it is taking place, but it is named as spontaneous and non-spontaneous. Spontaneous means this is a kind of reaction where it will be taking place of its own without any external help. The reactions will be taking place of its own. Hence, it is named as a spontaneous redox reaction. So, in this session, let us discuss what is a galvanic cell and how the construction will be made it and how the working will be made in the galvanic cell. Let us understand. Okay. So, first I will directly move to the galvanic cell. So already we have understood that a galvanic cell is a electrochemical cell which converts a chemical energy into electrical energy. In addition to this, we have also understood that here the redox reactions will be taking place and the reactions are spontaneous, which means to say that the reactions which happens of its own without any external help, the reactions will be happens of its own. Hence it is known as a galvanic cell, which is a spontaneous redox reaction. Now we'll see how to do the setup. Okay. To explain this, I have taken a two different container which consists of electrolyte. Okay. Here I have placed the two electrode in the two container. The one electrode will be act like an anode, whereas the another electrode will be act like a cathode. And these electrodes I have placed in a separate electrolytic solution. So first I will call this electrode as a zinc electrode which has been placed in zinc sulfate solution. Same ways I have placed the copper electrode on the copper sulfate solution. Understood? And also in order to connect these two solutions, I have placed an inverted U-shaped structure which is known as salt bridge. Okay, which is known as salt bridge. So it always connect the two electrolytic solution. So instead of mixing, for the transfer of electron, this salt bridge will be very much helpful. So you learn more about the salt bridge in the coming slides. Okay, and the entire setup I have placed in presence of electrical field. Hope you all understood with the construction. Okay. Now, already I have told that I have considered the one of the electrode as an anode, one will behave like a cathode. Here, the zinc will be act like an anode and copper will be act like a cathode. And one thing you have to remember that, especially at the anode, always oxidation will be taking place. What will happen? Oxidation will be taking place. Then what is meant by oxidation? Oxidation is a reaction in which the electron has been removed from the element. For example, if I say it is a zinc, okay, the zinc electrode will lose its 2 electrons and get Zinc2 plus. So here the loss of electron will be taking place, hence it is named as oxidation reaction. And here only the oxidation which is taking place on the one side, hence it is known as half cell reaction, which is known as half cell reaction, where remember the zinc loses its 2 electron and become Zinc2 plus and become Zinc2 plus. Okay, so it will be undergo oxidation. Next, coming to that side, that is the copper, where copper will accept these 2 electron, okay, and get reduced to copper. So where reduction will be taking place. Remember, especially at the cathode, always reduction will be taking place. And here the copper 2 plus, they receive the 2 electron which has been given from the zinc and get reduced to copper. So hence only the reduction which is taking place on the left hand side, which is known as half cell reaction. In the entire setup, you can see that both oxidation and reduction will be taking place. So I can write the overall cell equation as a redox reaction, where you can cancel 2 electron, okay, where the zinc react with the copper because it loses its electron and become a Zn2 plus and copper will be get reduced. So this kind of overall writing of reaction, which is also known as redox reaction, where the zinc will lose its 2 electron and get oxidized to Zinc2 plus, whereas the copper 2 plus or the copper which accept this electron which has been released from the zinc and get reduced to copper. So this is an entire cell equation for the galvanic cell. Did you all understood? Here remember, both oxidation and the reduction will be taking place in a separate half cell. If you combine or if you summarize these 2 reactions, you will get redox reaction. Hope you all understood with this galvanic cell, and what is galvanic cell also you have understood, and also you have understood about the how the construction will be made and how the working will be made. Now we'll see about the electromotive force. So why we need to understand this electromotive force? Because in case of galvanic cell, we have understood that the electron which has been released from the zinc, it will passes through this salt bridge and it will reach us to the copper, right? So it will reach us to the copper electrode, where the copper will accept this 2 electron and it get reduced to copper. So the free energy change of the spontaneous redox reaction, which will be involved in the transfer of electron from anode to the cathode, which involves what? The transfer of electron from anode to cathode. So this transfer of electron, which is mainly causes a difference, okay? So that difference is also known as electromotive force. So let's see what is the electromotive force, okay? Electromotive force can be defined as it is a difference in electrode potential between 2 electrodes when no current has been drawn from a cell. So what is electromotive force? It is a force, or we can say that it is the potential differences between 2 electrodes when no current is drawn from the cell. And always it has been measured by using potentiometer. By using potentiometer, we can measure the potential differences between the 2 electrodes. Why the potential differences will be happen? Because the electron which has been transferred from anode to cathode. So due to this process, the potential differences will be exist, that will be usually done by calculating the EMF. An overall cell reaction can also write by, or the cell potential can be taken by considering E cell, which is equal to E cathode, that is the electrode potential of the cathode, minus E anode. E anode, this is known as a cell potential, which is known as what? Cell potential. So what is the cell potential? It is the potential differences between the electrode potential of a anode minus electrode potential of a cathode. The differences between this potential difference at anode and a cathode, which is also known as cell potential. Remember, there is a difference in the EMF and also with the cell potential. What is the EMF? It is nothing but a potential differences between the two electrodes when no current has been drawn from the cell. Whereas in case of a cell potential, which is obtained by considering the electrode potential of a cathode minus electrode potential of a anode. Now let us discuss what is this electrode potential of a cathode and anode. So this will be obtained by measuring, that is, a potential differences between an element to its own metal ion at equilibrium. How to measure the electrode potential? It is measured by considering the electrode, or if you consider any metals, if the metal have been placed in its own ion, the potential difference will be exists at a particular equilibrium. That differences is known as electrode potential or a single electrode potential. To explain this, I have considered the single electrode potential, only half cell I have considered, okay. To this, I have placed the electrode which has been dipped in the same metal ion solution. Suppose, you can imagine this electrode as a copper, okay, which has been placed only in the copper sulfate solution. Which has been placed in a copper sulfate solution. Now you can imagine that the copper which has been placed in a same metal ion solution, right? So what will happen when you apply the electrical field? The metal can acquire either negative charges or with the positive charges. Is it right? When you apply the electrical field, this metal can acquire either positive charges and the negative charges. During this process, there is a potential differences will be developed with the electrode and also with this ions which has been developed in the solution. This potential differences between the electrode and with this ions, which is known as electrode potential. Which is known as what? Electrode potential. Hope you all understood the electrode potential. Remember, electrode potential is a potential difference which is developed between the metal to its ion. Between the ion. So which ion we are taking? The same metal, if you consider the same electrolytic solution you have to take. Okay. The differences between these two at equilibrium, which is known as electrode potential. And this is always measured in terms of volts. It has to be expressed in terms of volt and we can denote it in terms of E. That is why I have written here the E cathode minus E anode, that is electrode potential of the cathode minus electrode potential of the anode. Then, how does the magnitude of the electrode potential depends upon the other factor? As we have already understand that in order to calculate the electrode potential, we must consider the metal that should consist of a same metal ion, right? If you consider the different, then potential differences will become different only, right? So that is why the nature of the electrode, what we are using for this to know about the electrode potential, that is very, very important. In addition to this, we must know about the concentrations of the ion in a solution. So, the concentrations of the ion in the solution, that is also very important because the potential differences is mainly depends upon the electrode and also with the ion which has been formed in a solution. If it is correct, then the electrode potential will be exist. Then, a temperature. The temperature is another factor which mainly affects to the electrode potential, and the nature of the ions which has been formed in a solution, that is also very important. Suppose if you consider any electrolyte, if it is not forming any positive and the negative ions, then we cannot expect the electrode potential. That is why whatever you take the electrolyte, that must form both the positively charged ion, whereas a negatively charged ion must be formed in an electrolytic solution. So these are the factors which are mainly depends upon the electrode potential. Hope you all understood this topic. Now let's see what is standard electrode potential, which is also known as E0, Now let us understand what is standard electrode potential. Already we have understood that what is the electrode potential. So if it is saying in terms of standard electrode potential, then it is nothing but you can consider a same half cell or the half cell reaction you can consider. We know that for this we have placed the electrode, right? This is a electrode which has been placed in a same electrolytic solution. So which forming electrolyte. Okay. The potential differences which exist between the electrode and to this ions, which is known as a standard potential, or we can say that it is nothing but a potential, electrode potential, right? So which is known as electrode potential. Electrode potential. What is electrode potential? It is a potential differences which exist between the electrode to its own ions at equilibrium. Now, in order to express in terms of standard electrode potential, here I have considered the electrolyte which should be in the 1 molar concentration. So 1 molar concentration of the ions I have considered as an electrolyte, and also have maintained the pressure at 1 bar 25 degree Celsius, and also have maintained the pressure at 1 bar 25 degree Celsius. If you maintain this condition and if you observe the potential differences between the metal and its ion at equilibrium, then we say it is a standard electrode potential. So you can see from the definition, that is a potential differences between an element to its own ion in a solution at equilibrium when the concentration of the ion is 1 molar and the partial pressure of the gas which has been evolved is 1 bar at 25 degree Celsius, which is known as a standard electrode potential. Which is known as what? Standard electrode potential. And it is usually denoted by the symbol E0. Understood? Then, the value of this electrode potential should be considered as a standard reduction potential. Standard reduction potential, unless it is specifically mentioned as a oxidation reduction potential or oxidation electrode potential. So how to say that in terms of, suppose if you consider this as a reduction reaction and one is with the oxidation reaction, we have a relationship, that is a standard reduction potential which is also equal to a minus of standard oxidation potential. Here remember, always reduction will be taking place, and that side always oxidation will be taking place. So this is a differences between a standard reduction potential and also with the standard oxidation potential. Hope you all understood the standard electrode potential. What is the standard electrode potential? It is a potential differences between the metal to its own ion. So where the concentration of the ions have considered as a 1 molar. Okay, and the partial pressure of the entire gas which have been kept at 1 bar at 25 degree Celsius. Then the potential which is developed between the metal and to its ion, which is said to be a standard electrode potential, and it is denoted by E0. Hope you all understood. Then we'll see what is a Daniell cell. So remember, the Daniell cell is an example for the galvanic cell. Okay, we know that again the Daniell cell which converts chemical energy into electrical energy. Here, for my convenience, I have considered the are electrodes as a negative electrode, which is act like a zinc, and here I have considered the positive electrode as a copper. Okay, let's see the construction now. So this is the entire setup of the Daniell cell, which consists of two separate containers. Okay, so on the one side I have placed a zinc electrode in a zinc sulfate solution. Whereas another electrode which is act like a cathode, which has been placed in a copper sulfate solution. Now, what you have to consider here, I have considered the zinc electrode as a negative electrode. Here we have considered the zinc electrode as a negative electrode, whereas the copper electrode as a positive electrode. Okay. And also you can see that there is a salt bridge. So this is a porous bridge which connects the two solutions. Instead of mixing the two solutions, if you place the salt bridge, which allows the migrations of the ion from one solution to the another solution. And also I have placed the entire system in presence of electrical field. So it will be measured in terms of voltmeter. Okay. Now we all know that especially at the anode, oxidation will be taking place. What will taking place? Oxidation will be taking place. Whereas at the cathode, we know that reduction will be taking place. Remember, this is a anode and this one will be cathode. Do you all understood with the construction? So what does the construction says? The construction says that we have taken the zinc as a negative electrode, whereas the copper as a positive electrode. Remember, the zinc electrode will be act like an anode and which has been placed in a zinc sulfate solution, whereas the copper electrode will be act like a positive electrode, or you can say that it's a cathode which has been placed in a copper sulfate solution. And these two solutions are get connected with the salt bridge, which is a porous bridge which allow only the migrations of the ion. And also, we know that especially at the anode, oxidation will be taking place. Whereas at the cathode, only the reduction will be taking place. Now, let us write what will happen only at the anode. So, first I will consider only at the anode. Only at the anode, what it is there? Zinc will be there. We know that it undergo oxidation, right? So, zinc will lose its 2 electron and gets positive charges. Okay, since it releasing the 2 electrons, okay, so it is known as negative electrode. Understood? Next, coming into the cathode. At cathode, what it is happening? The copper will accept the 2 electron which has been released by the zinc and get reduced to copper. Since it accepting the electron, understood? Since it accepting the electron, hence it is known as positive electrode. Now, if I summarize these two equations, what you will get? First one is oxidation, second one is a reduction. In the half cell, only oxidation will be taking place. In another half cell, only reduction will be taking place. If you summarize these two, you will get a redox reaction. Now, I can cancel 2 electron and you can write a zinc plus copper 2 plus give rise to zinc 2 plus copper. Understood? So, this is the entire equations for the entire cell reactions which is taking place in the Daniell cell. Hope you all understood. Remember, especially at the anode, it will allows only the oxidation to take place, where a zinc electrode will be loses its 2 electron and get positive charges. Since it releasing the 2 electron, hence it is considered as a negative electrode. Whereas in case of cathode, we know that reduction will be taking place where the 2 electron will be accepted by the copper and get reduced to copper. Since in accepting the electron, it gets a negative charges, hence it is known as positive electrode. If you summarize these two different reactions, that is oxidation and reduction, you will get redox reaction. So this is the overall cell reaction which is taking place at the Daniell cell. Okay, where the zinc will lose its 2 electron and become zinc 2 plus, whereas the copper will accept these 2 electron and get reduced to copper. So this is actually how the entire Daniell cell can be represented and also how the construction will be made. Did you all understood with the construction and also with the working? The same reaction which I have written here, you can see that a zinc electrode which undergo oxidation, where the zinc will be loses its 2 electron at anode and these 2 electrons will be accepted by the copper and get reduced to copper. The entire cell equation also I have written here. After writing this, you can write the cell potential which is measured by voltmeter, because the Daniell cell will be measured, the entire electrical field will be measured by using voltmeter here, so that the cell potential of this Daniell cell will be become, that is a cell potential of this Daniell cell will be equal to 1.10 volt. 1.10 volt is the cell potential of the entire Daniell cell. So how the cell potential will be measured? By considering the electrode potential at anode and also at the electrode potential at the cathode. The differences between these two, you'll get the cell potential. Hope you'll understood with the working, construction and how to write the cell potential for the Daniell cells also you have understood. Now let's see what is the use and what is a salt bridge is. Okay, already we have understood that salt bridge is a inverted U-shaped structure which consists of non-reactive ions. Usually it consists of potassium ion and a chloride ions. Okay, it consists of potassium ion and a chloride ion, and also which has been dissolved in agar-agar gel. So in the agar-agar gel, these two are non-reactive ions will be placed. And what is the speciality of the salt bridge? So this salt bridge which allow the migrations of the ion from anode to cathode, and without the salt bridge, you know, the entire circuit will never get complete. So that is the first usage. And also we have understood that it allows the migrations of the ion, which allows what? Migrations of the ion between the two solutions. Instead of mixing, you know, it allows only the ions to pass from anode to cathode. And also it minimizes the liquid junction potential. And also, in order to maintain the electrical neutrality in a solution. What is electrical neutrality? We know that at an anode, especially zinc will be loses its 2 electron and become zinc 2 plus, whereas at the cathode, the copper will accept the 2 electron and become copper 2 plus. For this, there should be a balance between the right hand side to the left hand side, right? So in order to maintain this electrical neutrality at anode as well as with the cathode, this salt bridge is very much useful. Remember, it is always a inverted U-shaped structure which has been placed in between the two solution. Without this, you know, the migrations of the ion will not taking place. Hope you all understood the salt bridge and its function. Now, let us see how the sign conversion will be made, especially in the galvanic cell. In the galvanic cell, we have understood that they have called the anode as a negative electrode, whereas the cathode as a positive electrode. Why? Let us discuss. The electrode that are rich in electron and supplies them is a negative electrode, which means to say that at anode, we all know that the oxidation will be taking place, right? Suppose, imagine you have two cells which consists of electrode. So, let us consider this will be act like a anode and here it will be act like a cathode. Both will be placing in an electrolytic solution. We all know that, especially at the anode, what it will be undergoes? It undergoes oxidation. it undergo oxidation. Whereas in case of cathode, it always undergo reduction, which always undergo reduction. Since, especially at the anode, the electron-rich species are present, that is a zinc, right? That is why it loses its 2 electron. So, if the electrode which has a rich electron to supply for the other electrode, hence it is known as a negative electrode. Whereas the another side, we have considered the cathode as a positive electrode because it is an electron deficient electrode, because it is capable of accepting the electron. That is why this cathode will be considered as a positive electrode, because it accepts the electron because of the deficiency in the electron. So that is why, especially in the galvanic cell, sign convention is very important in the electrode. Understood it? And also, the electrons are continuously generated at anode and consumed at cathode. The anode is a source of electron and act like a negative electrode, whereas at the cathode, it is a positive electrode because it is capable of accepting the electron. This is how the sign conventions will be made, especially in the galvanic cell. Hope you all understood with this. We'll see about the symbolic representations of the galvanic cell. So, how we symbolize after the reaction? Let us see now. Especially to symbolize this, I have taken the example of the same cell reaction what we have discussed now. So, why we need to symbolize this? We know that especially we have taken the 2 different electrolyte which has been placed in a particular container, and also we have placed the 2 different electrodes. After the entire reaction which has happened, we must know that, or we have to represent this reaction symbolically. So instead of writing in words, if you symbolize, that will make you to understand easier. So that is why in the IUPAC system, we have a certain rule to place this elements. So let's see how to do it. Especially to symbolize the entire cell reaction, first we must denote the negative electron. So since in the first reaction, especially at the anode, the reduction will be taking place, right? Oxidation will be taking place. That is why I have placed the negative electrode, that is zinc. So first we need to write the negative electrode, which is followed by a single vertical line, After this, we need to write whether it undergo oxidation. So here the zinc will undergo oxidation and get oxidized to zinc 2+. So this happens only in the solution phase, right? So this is a electrode. This is a negative electrode followed by vertical line, and also which is followed by a zinc solution where the zinc will lose its 2 electron and become zinc 2+. After this, we need to represent 2 vertical lines. This 2 vertical line which shows that anode and cathode solutions, or anode or cathode, get separated by the salt bridge. After this, we need to say that which solution you are using in the other side. That is a copper sulfate solution where the copper will accept 2 electron which has been released from the zinc and get reduced to copper, which is followed by the positive electrode, that is copper. This is how we symbolize the entire cell equation by writing like this. First, what you have to write? The negative electrode followed by vertical line. This vertical line which shows the differences between the electrode to the electrolytic solution. Later, we need to write the double vertical line. Double vertical line shows that there is a differences between these 2 solutions, and this is nothing but a salt bridge. After this, you need to say what is the Cu2+. Cu2+ is an ion which has been formed at a cathode by accepting the 2 electron. After this, you need to write another vertical line followed by the positive electrode. This is how we can represent the entire cell equation by writing like this. Hope you all understood with how to write the cell representation. Now, after doing all those things, in the next session, we are going to understand how to measure the electrode potential. So already we have understood what is the electrode potential, how to measure it. Let us understand in the next session. Till that, take care and we will meet you in the next session. Thank you.